SciByte is produced by JupiterBroadcasting.com. Independent entertainment that's on demand and always thoughtful. Check us out. Hi everyone, you're listening to SciByte, Jupiter Broadcasting's weekly science podcast, and we recorded this one on Wednesday, December 21st, for release on December 22nd, 2011. My name is Chris, and joining me, like every single week, is Heather.
Hello there, Chris.
Hello there, Heather. Happy science to you.
Happy science.
How you feeling? Now, the show's coming out a little late this week because we both ended up getting sick, so we're back today.
Yes.
Thank you, science, for letting us heal faster.
Yes.
Thank you, science, for also getting us sick, you tricky bastard.
Yeah.
But, so apologies to some of you who were looking for the show in the feed yesterday, but here it is. We're back. We just missed a little bit. So what do we got coming up in the show today?
We're going to take a look at some of the feedback we've gotten, questions concerning the sun, solar cells, even SpaceCamp. We're also going to take a look at some of the news on some new extrasolar planets, black holes, some other news, and as always, take a peek back into history and up in the sky.
Always one of my favorite parts of the show, and plus that always is a great spot to get little nuggets that you can share with family, over the holidays, which is always good. I always like that stuff. It's like, look how smart I am. Did you know this is up in the sky this week?
Oh, yeah.
But before we jump into the news, do you want to cover a little viewer feedback we've gotten recently? In fact, we've got a few questions, like questions about the sun and things like that. Yep,
we've had some feedback, but some of the shows over the last couple weeks have been so just jam-packed, I haven't got to get to them all yet.
That's true.
So threw in a couple of this time. Somebody asked about, a couple questions about the sun. If the sun can't fuse gold in the side, why would any of it be there? Do scientists take that account when calculating its life, its weight? Does Mercury and Venus being closer to the sun, would they have heavier elements? So all those questions kind of have to deal with the formation of the solar system, the sun, the planets. So I'll kind of go through that real quick, and that'll kind of answer those questions.
Quickly cover the formation of the solar system, just real quick.
Well, maybe 5 minutes worth.
Okay, no, that's cool.
Concentrate it a little.
I mean, we're 2 minutes into the show, but hey, lay it on us. That sounds good.
Yeah, here we go. So throughout the galaxy, there are these dust clouds. Most of it is hydrogen and some heavier elements, seeded throughout it. Now, all the heavier elements that naturally occur in the universe are strictly from type 2 supernova. That's in those supernova, the star it has layers of all these various heavier elements. So supernova kind of seeded all the heavier elements in our solar system kind of in the gas. What probably happened, they think, is that a second supernova would have hit and a shockwaved this bubble of dust and gas that our solar system started off as, and sort of kick-started, it kind of moving and compacting. And so it kind of, in the center, you have this big ball of gas that starts compacting and getting hotter, at first from just friction, and then from, turning hydrogen into helium. So that started the sun. So
it's funny. It seems like it's such a simple little thing.
Yeah, just
when
really
you
simple.
Phrase it like that. Yeah. A little hydrogen, a little helium. Then you got the sun.
Then you got the sun. Poof.
It's funny how many things in the universe were created based on something else being destroyed.
Yeah.
Supernovas and whatnot.
Yep.
All right. So what's the next stage?
So there's the sun, and we can look out into the stars, and we can see different types of stars in different, in various ages. There's a middle group that's just kind of the norm. They do their thing. They live their life. And that's kind of what the sun is. It's one of those nice, normal, changes hydrogen to helium. It does its thing, and it'll get big and be a red giant, that kind of thing. So they can tell by how much hydrogen to helium it has converted to see kind of its age. So it's about 4.5 billion years old. It's got 5 billion years or so before the hydrogen runs out. And then it'll just move on to the next stage of its life.
Definitely enough time for us to get any business done that we need to get done.
Hopefully. Hopefully private industry or something else has, put us somewhere else by then. Hopefully.
I mean, 5 billion years, you got to figure that's a long enough time to at least get the spaceship thing figured out.
Yeah. I hope so.
Until but then it's just going to be a continuing problem because then the next sun we go to will eventually burn out.
Well, we just have to travel again.
That's
of course,
if
SciByte is around during that time, we will let you know where to go to hop on a spaceship.
There you go. Yeah. Tune in to get the weekly spaceship update.
Yep.
That'll probably be pretty in-demand service, I would think, actually.
Yeah, I know, right?
Yeah. The opportunities are big for us once the sun burns out. I like it, Mars. Good thinking.
Yeah.
All right. So that's... Okay. So now are we on to planets?
I think so.
Done with planets? Okay.
So
the...
So the sun has been made.
Tell me about the inner solar system.
The sun has been made, and it's surrounded by a dust cloud. Now, the inner solar system was too warm for volatile molecules like water and methane to condense. So that's why the outer solar system planets are all gassy and stuff, and the inner solar system are all rocky. It's because they were hot enough that they kind of stripped down that lots of fluff.
That makes sense.
Now, the inner solar system and pretty much the asteroids are made of a very similar composition. We're all vaguely made up of vaguely the same stuff. Now,
Stardust.
Yeah. It's about the same Stardust.
The same the components of that Stardust are about the same across all of them.
Yeah. Well, I mean, also if you think about it, these heavier elements that form laptops and mics and, the internet cables only make up 0.6% of the mass of this nebula. So that kind of kept that's also why the inner planets are all fairly small compared to the outer planets. Because
we're lucky we got what we did then when it all shaked out.
Yeah, the dense materials and the heavier elements were pretty much only limited, so they can only get so big.
So then, by the very nature of the elements that those planets use, they were kind of destined to never get much bigger. They were always going to have to be kind of that size. And if it could have been larger, like if we could have had Jupiter-sized planet Earth, then there would have been less resources for the other planets to go around.
Oh yeah, and also be quite a lot of more gravity.
Yeah. Oh boy. Yeah. Good point.
We might have 10 little short legs to kind of let us survive walking around or crawling around.
To hold us up.
Yeah.
Yeah, we wouldn't be able to be so tall, would we?
No.
It'd be pretty difficult for the human body of this Jupiter-sized rock planet to hold itself up.
Yeah.
That's interesting. What else you got here?
Well, since what I mentioned as, the inner planets are vaguely the same composition, mining any other planets, not as much. Of course, if we run out of rare metals here on Earth, or, we go through the ones that, we use up all this, or all of it is in use, then going to other planets, if we can do it the right way.
I'm playing a video you have in the show notes here of the planets being assembled, and it had this really cool music playing. I don't know if you heard that, but
heard a little bit.
That sounds so cheesy.
A cloud of interstellar gas and dust was drifting through space.
Oh, thank you, strange lady.
Thank you, elevator voice lady.
Yeah.
Or airport lady.
Pam, when you're done recording the voiceovers for the airport, could you come here and read the space script for us? Thanks.
Yes, thanks.
So anyways, I didn't mean to interrupt. I apologize. But you do have a bunch of really good video links of the formations and stuff in the show notes, and I was just looking at one of them, and that's pretty cool. There you go.
Yep. But
anything else you want to cover on the feedback there?
Yes. Okay. Along with that is that there are a lot of these heavier, the metals very close to the surface of the Earth, and that is in part there is a theory about that is mostly accepted about how the moon formed. That's where another planet, maybe about a third of the size of the Earth, smacked into it. They both kind of tumbled around. The moon got knocked off, or a whole bunch of dust got knocked off of the combination of these two planets, and that formed the moon, and that would be kind of why it's locked in, and we always see the same side of the moon. But what that also did is it got the surface of Earth and the surface of this other planet all kind of jammed up on the top of the Earth. Yeah, on the surface of Earth. So that would have increased the number of minerals and heavier metals and things like that on the surface of the Earth.
Wow. So, I mean, just think about the implications of what you're saying is that the thing that makes it possible for Apple to build millions of iPhones and Google to build millions of Android devices with all these precious metals and everything, the thing that's making that possible for us to be able to get those resources is there's a good chance another planet smacked into Earth at some point and spewed its contents all over our surface to make that stuff more readily available.
Yep.
So if another planet hadn't collided, we might not have iPhones.
Yep. If another star hadn't blown up, and if we didn't have a two-planet car collision on the highway of orbit, no iPhone.
Wow, space is profound. I mean, that is a pretty big deal. And no moon. No moon either.
No moon.
Which is,
but
I mean,
no
can you imagine no moon?
That'd be sad.
Yeah. I mean, no gadgets, no moon. I mean, those resources, those minerals would still be here, but they would just, I guess, then in theory, be way farther down in the surface of the Earth.
It'd be more difficult to reach.
Huh. Wow. God, that is so lucky.
Mm-hmm.
I mean, you'd never think getting hit by another planet would be something you'd be thankful to happen, but if that hadn't happened, we'd be screwed. So there you go. Well, that's one of the most interesting little factoids I think I learned today. See, that's exactly what I was talking about at the beginning of the show. Little factoids that you can go to family and you can tell them these interesting things, and they'll be like, "Shut your face," and then you can be like, "Go check the SciByte show notes. I tell you, it's the truth."
Yep.
Right. Yeah.
Yep. When they ask, questions, the conversation goes somewhere weird, you'd be like, "I'm glad I listened to SciByte. I can just start spewing interesting information."
Speaking of questions, thanks to the people who sent those into SciByte@JupiterBroadcasting.com. Those were some good questions. I like that. Anything else you want to cover in the feedback? Was there any other ones, or do you want to jump into the news?
There was a story pointed out to me on my Twitter account of a solar cell that was had more than 100% quantum efficiency. So it was...
Wow.
Yeah.
Like, these are like super efficient.
Yeah. The number of electrons flowing out was greater than the number of photons coming in.
That's a really big breakthrough. I had a client who was attempting to build solar panels for 2 years, and they couldn't get the efficiency up nowhere near that high.
Yeah.
And they gave up.
Yeah. Well, they're notoriously difficult they have been, they've taken great leaps in the last few years. But when I was in college, it was, they still weren't all that good. But my university had an observatory on top of a mountain, and you couldn't get to it for so many months of the year because the roads were closed off on the mountain. And some company was testing out some solar panels, and they're like, "Hey, if we give them to you to test out, will you do it?" We're like, "Sure, we can get power. That's great."
Yeah.
So what this company is doing is they've created little tiny solar cells about the size of a ballpoint pen, and they grow these little semiconductors and then transfer the dots to a wafer.
So they're like they're almost like it's almost like the LED approach to solar cells.
Yeah.
In a sense, because the solar cells that I'm more familiar with are more like silver dollar sized, if not larger.
Yeah.
Interesting.
So they've done this. So they pack all these together. And then they also have some lenses on the collector that concentrate light up to 1,000 times on these tiny solar cells.
Have they not done that before? Because that does seem like that makes it's like when you want to burn an ant or melt an army guy, you take a magnifying glass and get it in the sunlight.
They've done it in various ways before. I know that there are also solar cell, fields where it's, curved mirrors are pointing it back on the solar cell. These kind of things. So these little dots, they're made of lead and selenium, about 5 nanometers in diameter. And they're also kind of covered in long organic molecules to keep the little dots from clumping together. They're just so tiny that they kind of have to have something on top to keep them from all bumping into each other and clumping up.
That's interesting. They had to come up with a little solution to prevent that wouldn't take away from the efficiency.
Yeah.
That's probably a little bit of a trick,
because they were so
actually.
tiny. Yeah.
That's got to be a little bit of a trick, yeah. That's interesting. They say they've already invested $7.9 million. They're actually building a field of these.
Yes.
5 megawatts worth of panels.
Yeah. Their goal, they're trying to build something that would generate electricity at under 10 cents per kilowatt hour.
Huh. Oh, boy. That is really awesome.
Yeah, that's saying something.
Excuse me, I had to cough, sorry.
No problem.
I'm still kind of sick, so I'm still fighting the cough a little bit. But I tried to cough off mic, so I apologize if I got that in mic a little bit.
It's okay.
Wow. Who was it on Twitter that sent you this? This is a great link. This is really interesting.
I don't recall right now. I don't think I put any names in the...
Well, there you go. What is your Twitter handle? That way if people want to tweet you stuff, they can find you.
It is JB_MarsBase.
Which also has an underscore in it, right?
Yeah, Mars_base.
So it's JB_Mars_base.
Yes.
If you want to get a hold of it.
Lots of underscores.
Any other notes on that link?
I don't think so. I wasn't, like, when I first looked at the story, I was kind of in the, partially not feeling well zone when I was trying to put it together.
Yeah.
So when I was looking at it again tonight, it made more sense.
Isn't that exciting? That is really, really exciting. I mean, that is awesome. Now, did you also want to make a mention about SpaceCamp before we jump into the news?
Yeah, I had a listener who's in the 4th grade ask me if I had ever been to SpaceCamp. And the answer was, no, I didn't. Everything didn't collide for me at the same time. It was something that I was interested in.
Oh, I bet.
There are various programs for various ages and adults. There's also, people don't often know, they have a high performance flying, like if you want to be a jet pilot or something. They have another program for that.
Cool.
Yeah.
You probably, like, is it for kids or for adults?
It's the same as SpaceCamp, where there's a couple of different age groups for kids, an adult program, a family program.
I totally want to do the jet one.
Yeah. Those are like 6 days.
Well, that would be a little hard. We would have to sort of plan SciByte well for that one, right? Because 6 days. Maybe you think they'd let me do SciByte from SpaceCamp?
Maybe.
Because that would be really cool. SciByte on location at SpaceCamp.
At SpaceCamp.
That sounds neat. I wonder if, you know what would also be really cool is like a dad and kids kind of a thing. It'd be fun to like take my son Dylan to something like that.
Yep, there are family programs where you can have one parent and a kid, or a couple of kids and parents.
That is really neat. So you could have you could have a couple of friends go to and stuff like that. Oh, that's nice. I want to do that.
Yep. Now, it is a little expensive.
Oh.
So one alternative that I like to mention, because I've actually worked with them before, is the Challenger Centers, which are, they're like mini missions. It's got like a little mini mission control, and then a little, space station or something else. And you split up into 2 groups, and you'll have some sort of mission. Maybe it's go to a comet or go to Mars. I think they even have Earth science ones. Cool. And so you'll do like an hour or so in one. Mission Control has their little binders of information that each team has to go. And so there'll be, there's communications and there's science, and so there's all sorts. Just like it's like split up very much like, the real Mission Control. And then the other side will have, maybe you'll have little robots, or, put your hands into the glove box and, you're typing in your information to get science materials, and you have to work with your team on the other side. But those are
so cool.
If they have them in your area, then I know they're spaced out across the U.S. and they're still kind of growing. Yeah. Oh, that was a good catch.
Yeah, thank you. And it looks like I thought I saw a schedule on their site here, but now I don't see it because I was wondering they probably only do it at certain times of the year too. I would think, right?
SpaceCamp?
Maybe. Yeah, does it all year round?
There are various times that it happens.
They should hold it in the winter so it's cold like space. Space camping. I don't know. So the Challenger Center is the other one, huh? And that's the one you said you'd been to?
I'd been to it, and I've also helped run it. I helped.
Oh, that's neat.
There was one attached to the observatory. I did a lot of volunteering at when I was younger, and they had a little Challenger Center built in next door. There were a couple times where we'd have Boy Scout troops or Girl Scout troops where they'd come. They do half the mission at night. We'd show them the stars. Maybe take a quick trip around a path in the park. They'd sleep, and then the next morning we'd wake up and we'd do the rest of the mission.
Do the mission.
But otherwise, But otherwise, it was just sort of random, or I'd help them out. Or if it was a really cloudy night, just sort of clouded up very quickly, then it was an alternative for people instead of, staring at a telescope instead of through it.
That is so cool. That is so cool. I didn't know you did that, man. I would love to do volunteer stuff like that if we had anything. I don't think we have anything like that in Washington.
Yeah.
That's a pretty
I
neat thing.
was lucky to run across that because it wasn't something that was really close to me. So
you traveled, huh?
Yeah, it was about a 1.5 hour trip.
Oh, okay. Okay. Yeah, it's a bit of a drive. Yes.
Yep. I was very lucky to have nice taxi parents.
Oh, you weren't old enough to drive yourself?
Oh no. I started working at that.
Lucky then.
I was starting working at the observatory when I was 12.
That's so funny because that's about when I was doing my first IT work. So
that's funny.
Sometimes you just start young.
Yep, I'd be at the telescope. One of the older guys, they couldn't leave me alone in the big telescope because, liability reasons. They had to have somebody close to 18 or over 18. So he just kind of sit back and let me do it. And I'm like, hi. And everyone's like looking down at me. Yeah, he was there to supervise.
Yeah.
And everyone just kind of looked down at me. They're like, what are you doing here? Teaching you about the sky.
Right. Yeah, imagine a 12-year-old going to fix teachers' computers and things like that and telling them how they should be doing it better.
Oh, yeah.
Imagine how well that went over.
Yeah. Was it during one of my finals in high school? It was like the calculus test. The poor teacher. She teaches calculus, but she was trying to set up this new computer, and she'd just be frustrated. And about every 5 minutes, someone would turn their paper over, stand up, go over and help her out with something real quick, and then come back and sit down again. And about 5 minutes later, somebody else would stand up, go over, help her out with something, and then sit back down again. It's like we're all taking turns so that we didn't have to take out that much time of our test.
Right.
We're like, all right, it's your turn. Go help her.
I like that. It's a good way to work it out. That way you guys get the workload a little more distributed.
Yeah.
No one person takes the hit in their class load.
Yep.
Should we move on to the news segment?
One thing I wanted to comment on from somebody in our chat room about the solar cells. Okay. They said, over 100% efficiency, totally not possible? Likely.
Right, right.
What happens is that the light has various energy levels. So in the higher energy level spectrum of light, these photons can hit them and actually spit out 2 electrons instead of 1.
Whoa,
so you
really?
Kind of get, occasionally that'll happen. And also, in solar cells, there's a lot of waste heat. Yes. So if you don't waste all that energy into heat, or you can kind of reconvert that, then you can increase the efficiency.
There you go. That was kind of kicking around the back of my mind, but I realized that was the big thing about the news story is how efficient it was. So there you go. All right, now with that out of the way, it's time for the SciByte news. What do we have first? What's our first story this week?
There were some Earth-sized planets discovered orbiting another star.
Yeah, I saw this. Now, this is big, right? Because they are, but they're hot. They think they might be super hot, right?
Oh, yeah, super hot. But, I mean, prior to this, the smallest planet we've been able to discover was just a little under 1.5, the radius of Earth. So it was almost 3 times the volume. And this star is a little cooler than the sun, about 950 light years away. It has 5 planets surrounding it.
That's exciting.
And so both of these planets...
It's a big active solar system.
Oh, yeah. And they've done some looping around because it's actually kind of funny. There's a large gas planet, one of these tiny Earth-sized planets, another gas planet, another Earth-sized planet, and another gas planet. So kind of big, little. So they've probably done some flip-flopping in their orbits.
This was discovered by the Kepler Observatory, right?
Yes, it was.
Now,
yes,
the Kepler just keeps kicking ass.
Oh, yeah. Completely kicking it.
Yeah, really. I mean, like a lot of the big discoveries we've talked about in far-off space on SciByte since we've relaunched has been via the Kepler array.
Yep. And it's like, and here's another announcement from Kepler. And
huge.
Yet another one.
So there is a possibility like that Earth-like sized one could be rocking some life.
Not
Right?
these. Not these.
Oh.
One of them has an orbit of about 6 days, and it's like 85% the radius of Earth. But its temperature is a little more than 1400 degrees Fahrenheit or 760 C. It could melt glass.
Yeah, that's not probably very habitable.
No, not entirely. The other planet isn't much better. It has about a little under 20-day orbit, a little bit larger than the Earth, just by a hair. Its temperature is only 800 degrees Fahrenheit, 426 Celsius.
Is it possible something might live in that?
Not that we know of.
Yeah, okay. I was trying to think of like one of those deep-sea creatures or something by one of the aqua underwater volcano things or something. I was hoping you'd say, oh yeah, no, those volcanoes underwater, they're about that temperature, so maybe. But that's not what you said.
Oh, no, that's not what I said. It's not evaporating the ocean.
Right. Yeah, that's a good point. It's not so hot that it's evaporating the ocean.
Yeah.
So yeah, that's a big problem. If there any water those planets are gonna have, it's gonna be in a gaseous form.
Not even gaseous.
No,
just be nothing. Not in any way.
That's a pretty big letdown. Way to go, Kepler.
Yeah. But I mean, we have discovered now, Kepler's discovered a planet in the habitable zone, and it's discovered planets that are Earth-size. So they're kind of hoping that this combination will occur at some point.
Well, I mean, so what we do know is that they've looked at only a small fraction out there, and they've already found a lot of really good stuff.
Yeah,
so,
it's the amount of sky that Kepler's looking at is only about, if you put out your hands up into the sky, about 2 hands. That's about the size of it.
It's already found this much stuff.
Yeah, well, it's taking about images of about 150,000 stars every 30 minutes.
Wow.
Yeah.
And that's so do they have any stats on like how many stars it looks at versus how many planets it actually finds? Like any kind of success to failure ratio or anything like that?
The more they look, the more they find that planets are more the norm.
Oh,
for a while they thought, no. And they're actually finding more and more planets, and they're like, maybe they are kind of more the norm than we thought. They even saw that planet around the binary stars, which they thought totally couldn't happen. Because there are a lot more binary stars out there too.
Right.
So there are all these discoveries that there's like, that's cool and way different.
All this stuff could mean that it could be it is potentially a very populated space. Just could be lots and lots and lots of planets out there. And the more planets there are, the more likely something's alive. Even if it's just a leaf, I'd be happy.
How about a little amoeba thingy?
Yeah. Oh boy, I'd be thrilled. Mars, I would be beyond happy. I'd be thrilled with that. I really would.
Hopefully not a bug that would get us both sick again.
Yeah, that's true. That
would be evil.
Any other thoughts on this story?
Well, generally when they confirm these planets, they're always kind of throwing us the loop about, we've discovered this many potential planets. And then generally to confirm it, they take Earth-based telescopes that can look at the spectrum of these stars very detailed and see the little shift like as the
Right.
planet moves back and forth and shift it.
Mhm.
These
Mhm.
planets were too small to do that. So somebody out there had to create a software that could run with about 30 different people went into it, and they were able to run millions of simulations to rule out any of this, consistent stellar dimming.
Oh, interesting.
And they found that for one of the planets, it was over 3,000 times more likely that it was actual planet, and for the other one, it was like
Huh.
more than 1,000 times that it was, more likely that it was an actual planet.
Now, this is kind of a left field question, but do you know when they were talking about how they had to create the software to identify these planets because they were too small? Were the planets they talking about were they the Earth-sized ones? Are Earth-sized planets too small?
Yes.
Oh man, but that seems like the sweet spot. So the sweet
Well,
spot's
yeah.
too small?
Well, you get so small, and it won't really shift the sun enough for us to be able to the star enough for us to see. So they kind of had to create. Someone had to create some software that
Well, now they
could
have it. That's good.
run all these simulations to be able to say yes.
Yeah. Well, that's good. I mean, now that they have that, maybe now they'll be able to find even more Earth-like planets. That's good. Interesting enough.
I did mention that there all this data going out, and actually they've made some of it available to the public. There is a website out there that means that anyone can log in and pull up some of the data.
Oh.
And if you see some dips, you mark it and you submit it.
They actually have go out. Oh
yeah,
my
they have a
gosh.
couple of these different types of programs where it's like,
that's cool.
If you're the first one to happen to say this one, and it actually turns out to be something real, then your name will be listed as a co-author on whatever papers come out about it.
That's really neat. That would be really neat. How geeky is that? That's like a more manual version of SETI, kind of. Only you're not looking for life. You're just looking for planets.
And they have these different types of programs. There's ones for the Mars rovers. It's like, hey, look at this. This is a rock. This is something else. And there's all these type of programs where there's just so much data that with all the computer programs you want, it can't really identify things as good as a human brain.
Mm-hmm. Not yet.
I mean, you can identify loads of faces. Computers are just now sort of being able to do it.
Yeah. That will improve over time, of course, and then they'll just be able to apply that improvement to, they'll just make their searches even better. They can just augment the human version of the search.
Yeah,
it's cool. Do you are you ready to take a pause here and talk about a book?
Sure.
That's our standby tone. I like that tone. You know what I want to tell people about is here on SciByte, we have a couple different ways you can help support the network. One way is great because both Heather and I are playing Star Wars: The Old Republic right now. There's a link in the show notes. Well, you can buy the game too, but I actually figured some people might be wanting to buy that time card now because you can buy one time card at a time, right? Mm-hmm. And then you get yourself like 30 or 60 days worth of gameplay. And they limit one quantity only available because I think they only let you buy one at a time. But if you're out there playing Tor and you're thinking about getting yourself something, check out that gift card. Or but it's a gift card for yourself, really. It's a time card.
It is useful for those people who don't have a card, or some people in living in countries outside the U.S. have a little bit of difficulty with that.
Or people who just want to go month to month for whatever reason.
Yeah.
It's good for that too. I actually, though, have an audiobook pick. This is an interesting one. It's a very sciencey book pick, and it's written by a former FDA commissioner, and it's called The End of Overeating, Taking Control of the Insatiable American Appetite.
I was fixated on those cookies until I forced myself to pull away. At some point, I noticed that I'd moved my right hand a few inches closer to them, but I had no conscious recollection of my decision to act. I tried to concentrate on reading the newspaper, but I kept glancing back to the plate. Feeling vaguely uneasy, I headed to my upstairs office, which is about as far away from the kitchen as I can get. But even from that safe distance, I could not fully shake the image of the cookies. Eventually, I left the house without having eaten them, and I felt triumphant. Hours later, I headed to Cafe Greco, a North Beach institution where the cappuccino is said to be the best in the city. A large glass jar filled with homemade cookies sat on the counter. I ordered an orange chocolate cookie and ate it at once. I set out to understand what is driving these kinds of behaviors.
Cookies.
This book is interesting because what he does is he uses his time as the FDA commissioner to sort of break down what the companies do to trick you into just having to eat and wanting to eat more. And it's actually a fascinating science of how your brain interprets foods and the associations it makes with them and how they kind of play on that a little bit. I mean, I'll be honest with you, it might make you a little angry, but it does kind of make you realize that the food out there is a product that they market to you in very specific scientific ways. It's fascinating. It's got a great review on Audible. And it's not really a diet book per se, but if you've thought about diet, this will help you frame things and put it in the right frame of mind. So here's what you can do. Link in the show notes if you want to buy this book through audible.com. We only get credit if you do use the link in the show notes. And if you sign up for a subscription, you can get this book for free. So, and if you cancel after you signed up, you get to keep the book. They don't revoke it. So you sign up, you get the book for free. If you want to keep it and you get the membership, that's awesome. If you don't, you cancel it, get the free book. It's awesome. So link in the show notes. And again, the title of the book is The End of Overeating, Taking Control of the Insatiable American Appetite. And there you go. It was a good book. Yep. It was a really good book. It really made me kind of realize how so many little things out there that we take for granted are sort of orchestrated by the powers that be. You know what I mean?
Well, more than that, I saw a science article maybe a couple months ago where it said when you eat like French fries or chips or something like that, that eating it produces the same chemicals in your mouth or kind of in your blood to a smaller degree, but that marijuana does.
Ooh, really? It's
so
interesting.
that
maybe that's
desire,
why the two
that
things
hook,
go great together.
well, more like that addictive hook that you can't, you can't stop. It's like,
it works
why you
into your
can't eat
brain's
just one
reward
French
system.
fry?
It's all part of the reward system and how they've conditioned you to actually sort of create that. It's a great read, and yeah, it touches on some of that. So I think people would really like it. There you have it. Should we move on to the SciByte? Newsbite.
Yes.
Very dramatic. I liked that. I felt like that one was flowing through me.
Yes.
Being sick be damned. It's time for the Newsbite. What do we want to talk about today?
Yes. The smallest black hole has been discovered.
Oh, that sounds adorable.
I know. I mean, black holes, a lot of them reside at the centers of galaxies. They swallow everything into them. They always say, not even light can escape. Right,
and if you've
some
watched
of the largest
Andromeda,
ones
they also cause time travel, by the way.
Yeah, of course. Obviously. You can sit there in a suspended animation until someone tries to, tractor beam you out.
You're an Andromeda fan.
Yeah.
All right, so what's the interesting details about the littlest black hole ever found?
So most of these big ones, could swallow up our whole solar system several times over pretty quickly. Now, this one probably could represent the lower boundaries of what a black hole would mean. It's only about 3 suns big.
Oh.
It's only got the mass of about 3 suns. This thing is tiny.
Right.
So when they saw it, they saw this X-ray emission that's distinctive pattern from a black hole. But it was so faint that they said, this is either really tiny or it's in another, galaxy, which we severely doubt. But what also is that, like an EKG for your heart, these black holes will have a time frame. They have a little heartbeat, as it were.
Oh, interesting.
Now the smaller, the quicker the heartbeat, the smaller the black hole. And this one had one that was just really fast. So the combination of how dim it was and the fact that this little heartbeat was going so fast meant that it's got to be a really small black hole. They were able to sort of guesstimate its size. So it's kind of interesting that they've discovered this and they kind of can tell the information about its size and distance and stuff from just a little bit of data.
Absolutely. It's incredible. You ever wonder if sometimes they get this stuff and you're like, well, what if they just interpret this wrong? Because this sounds a little too incredible. Maybe it's just the wrong circumstance of data telling them the wrong thing.
Well, by the time they actually publish this kind of stuff.
Yeah, okay. They go through they really go through.
Yeah, sometimes when you look at this, like if you actually could see the data for this was, the latest data for this may have been a year ago. It was probably, a year to 3 years of data.
Yeah.
And it's a long time before they actually publish anything.
Independent, verifications and things like that.
Yeah,
too,
they got to verify. Then they'll publish to, a scientific journal. And then from there, it'll make it into, dispersing into the science websites. And then if something's really cool, then it makes it onto the major news networks.
And on the SciByte.
Well,
It made it on the SciByte before it makes it on the major news network. You guarantee it.
Yeah.
You guarantee it.
Yep.
I'm just on top of it.
Absolutely.
Do you want to talk about this plant-eating dinosaur?
Yes. For the first time, the presence of a large-bodied herbivore, one of the sauropoda, was discovered in Antarctica.
Oh,
Now,
okay.
sauropoda, these are the big long neck, long tail.
Right.
This particular group has over 150 recognized species. But the identification of this suggests that these titanosauruses, these big plant-eating sauropods, were globally distributed. They were pretty much over the entire planet at the late Cretaceous period, which is kind of the last period of the dinosaurs.
So they're pretty common.
Yeah. What's kind of interesting is that they were able to tell what kind of dinosaur this was just from like the pieces of one or two vertebrae.
That's so awesome.
Because they have this type of dinosaur has a very distinctive, like, ball and joint vertebrae.
Oh, okay.
So they're able to see that, and they're like, aha, this has to be one of these, precisely. And by the size of it, then they could kind of get a better idea of the species of it.
That makes sense. Boy, it's like, because, they're very unique, identifiable bones. And so they start seeing these types of bone structures all over the world. And then they can kind of piece together, these guys must have been everywhere.
Yeah.
Maybe they're just big travelers. Because, they used to say, too, that, like, the continents were more interconnected, so it would be easier to travel around.
Yeah. But it just means that this type of dinosaur just was everywhere there was land.
That's really cool. That is interesting. So maybe possibly the most common dinosaur.
Yeah.
I wouldn't be too surprised, right?
Yeah. I mean, these guys were so big, there wasn't necessarily a lot going after them when they're, grown up.
Yeah. Yeah. They're probably pretty low on the predators list just because of their overall size.
Yeah.
Huh. Any other ones on that one? Any other thoughts?
No, I don't think so.
All right, it's cool. Because I want to talk about this comet that you have here in the show notes, because I see some pretty video, too.
Yes.
All right, tell me about it.
So I think we've mentioned it once or twice, but now that we have such a big view on the sun, we have 306 degrees, occasionally we'll see, comets dive ball into it or go to try to orbit the sun a little too close and they just die. This one we saw head into the sun and, we're like, oh, the Earthbased observatory just kind of saw it heading that way. And we're like, oh, bye, comet.
Well, I'm actually... That
then we
doesn't
saw
look like
it
a
coming back
comet to me. That looks like a bird of prey. Yeah, that's going around the sun. That's time traveling is what that is. That's no comet.
Oh.
Yeah, that's why it survived.
Of course.
You can see these guys just need to call me on this kind of stuff. It's pretty clear. You can tell by the arc that they're trying to go back to about 1987, it looks like.
Okay.
Oh, sorry. Sorry. I'm a
Hey, if they can identify a giant dinosaur by a couple of pieces of vertebrae, why can't you decide that they're going back to 1987 with just a little swoosh?
That's a pretty good point. It does kind of seem like that. That seems like fair game to me.
Yeah, I mean, you're quite the expert in Star Trek, so why not?
I do recognize all of these things. So I guess nothing too interesting other than it just didn't pass close enough to burn up is really the moral of the story.
Yeah, just that we're quite surprised when it did. We just kind of saw it going around the back of the sun. And we're like, oh, that's the last we've seen of that. And it actually came back the other side. And we're like, whoa, it actually survived. Interesting.
Why don't we do a little spacecraft update? Because previously on SciByte, on 22 and 23, we've talked about this, right? Yep. So that was back in November, so it's been a little time.
Yep. So we mentioned it before, but it has the little radiation assessment detector that is going to, read the radiation on the surface of Mars. So when we send our astronauts there, But what it's also doing, it's got this little coffee can sized instrument has a secondary mission of it takes radiation readings on its way to Mars. So it downloads the data every 24 hours, and it's just taking this data as it travels to Mars. So it's taking it can kind of see the radiation through space between Mars and Earth. And they're already seeing at this point, about 32 million miles away, that the radiation levels are about 4 times higher than they were on the launch pad.
Oh, geez. So what does that mean?
Well, if it stays at that level, then that's one thing. But what it will do is we can see what kind of radiation levels there are in between the planets and on the surface of Mars. And then we'll know how much radiation we have to protect, how much we need, what kind of shielding we need.
What we have to prepare for.
Yeah.
That is very useful, isn't it?
Yes.
Because you don't want to show up and get cooked.
No, that's generally not fun.
Yeah. All right. So when they get down there, this thing's going to get a kind of an idea of what maybe the safer locations would be as far as human colonization, right? So it's one of the data this thing's doing is potentially some preliminary searches. Am I right on that assumption?
Well, it is a rover. I mean, it's much larger than the other rovers, but it's only going to drive around so much.
Right.
But they'll kind of get a better idea about what it is on the surface.
Right.
It may not be the same everywhere, but it's going to be roughly similar.
And where they are sending that thing, they have a pretty good idea of what's there. Like that area they're sending to is like kind of like a known good thing, a known good location, right?
Yeah.
Yeah. Okay. Well, that's cool. Man, it's fascinating it's fascinating just as this thing is even on its way to be able to start to get information like that. It's already being useful. That's really cool.
Yep, and it actually started working about 2 weeks earlier than they thought it would.
Yeah, wow. How about that? Well, that's awesome too. Good job, guys and gals and gals. I don't mean to disparage. Sorry, Heather.
It's okay. It's okay.
Are you ready to go on to the SciByte calendar?
Sure.
This science calendar, as we like to call it here on the show. All right, well, you know what that means. That means it's time to jump into the time machine because we have to go back in time. Oh, I got to turn that up. Oh, yeah. Oh, yeah. I'm feeling very quantum right now. Oh, yeah.
Yep.
All right, so step through the wormhole and I see 253 years ago, December 25th, 1758. What do we have?
The predicted return of Halley's Comet. Now, there are clear records of the comet made by the Chinese, the Babylonians, medieval Europeans, dating back to all the way back to 240 BC. Now, these were all separate observations, all these different times that it would come back. It wasn't until 1705 that a man named Edmund Hubble thought that maybe these were the same comet.
Aha. Isn't he a
so
clever
he saw
guy?
it, and he said, I bet this thing's going to be back in 75 and a half years. And in 1758, sure enough, some German farmers saw it, and they realized, yeah, this thing has an orbital period of about 75, 76 years.
Then they figured that out.
Yep.
On Christmas, 253 years ago.
Yep.
Oh.
It orbits it actually orbits in the opposite direction that all the other planets do.
Ah.
But it's kind of peanut shaped. And the last time it showed up was 1986. So the next time it's going to show up is mid 2061.
Well, I'll be sure to keep an eye out for it. You'll have to remind me as it gets a little closer, though. Okay.
Yep. And we'll remind the audience on SciByte.
Yes. Now, let's go 73 years ago, December 22nd, 1938. Boy, this sounds classy already. What was it?
The first coelacanth was rediscovered. I may have mispronounced its name, but...
The what?
The coelacanth. Yes. This is a fish that we found in fossil records. You know, in any of these fossilized records, we're like, oh, cool, fossilized record. You know, animal, super dead.
Yeah, super dead.
Yeah, not just regular dead, but super dead.
Right.
So in
you
the
have a
Museum of
YouTube
East
video
London
here,
in
too.
South Africa,
Yeah.
there was this a curator who noted in some local fisherman's trash fish pile what looked suspiciously like this fossil of this coelacanth that lived, that everyone had thought it had been extinct since about 65 million years ago.
Oh, wow.
This thing is about 6 feet long,
Huh.
and it's a little bit structured differently from modern fish. Its heart is more like a straight tube. Its poor brain is filled with like 98.5% fat.
So the old brain wasn't too important for this guy.
No, its little brain case is only about 1.5% actual brain.
Well, I guess, for swimming and eating, that's about all you needed for this guy.
Now, there are a handful of these species of plants and lizards and fish and things that we thought had been extinct and were discovered again, but this is definitely the most famous. That some ancient fish that we thought had been dead for 65.5 million years.
Yeah.
And we find it again.
That is really something.
Mm-hmm.
It's funny how that can happen. It just doesn't seem like our planet's that big anymore.
Yeah. And that it's practically the same as it was then.
Well, I guess if it works, it works. You don't have to make any changes. Yeah. What do you say we go just 25 years ago, December 23rd, 1996?
86.
86, sorry, of course. I scrolled down as soon as I went to read the dates. That's why I was like, what day was it?
Yep.
It
was the first non-stop, round-the-world flight without having to refuel.
Oh, wow. I'm actually surprised that it took until 86 for like an airplane, I'm guessing.
Yeah. Well, some of these were around the world or had to stop to refuel or refueled in mid-flight. But this made it all the way around the world without fueling up again.
Yeah. Yeah. That's pretty significant. And I suppose it had to happen once the engines and fuel got efficient enough, so it would take a little while. It would take long enough to get to that point.
Yep. It was by Rutan and Jaeger, and it flew, almost 25,000 miles in about 9 days, 3 minutes. And
the awful part, though, was the cockpit, huh? It was a tiny cockpit.
Yeah, these are
thing.
2 pilots, and their original plan was, one flies a couple hours, one sleeps, and then they trade off. But
like
it was
a car trip, like a road trip.
But it was about the size of a phone booth.
How do you sleep in that?
Yeah, it really wasn't working out for them. They were like really worried. They're like, we're going to like crash into the ocean because we can't sleep.
Well, who would be able to sleep under those conditions? Like I took a road trip with Jeremy down to California, and I could barely sleep because heck, it's a fun road trip. I mean, I can only imagine if I'm doing one of the first flights around the world without having to refuel. I don't think sleeping would be on the top of my mind.
Yeah, they also had. I mean, they had to cut the fuel. The extra fuel pretty close. But they had to divert around one big storm.
Oh,
and
really?
they also had to divert, I don't remember which one, but they had to divert around a country because the country refused to give them airspace.
Oh,
They're like,
I heard
no, you
about
can't fly
that.
over us.
Right, I heard about that.
You're not allowed to fly over us. So they had to go around the country. And they landed back in California with not a lot of extra fuel.
Pretty close, huh? Cut it close? Well, they made it,
it had
though. Good
really
for them.
big wings. Oh, gosh. When they took off, it had these long wings. It took a really long runway to actually get up off the ground. And they actually knocked about 1.5 feet of wingtip off of both sides trying to get up.
Wow. Talk about
So they
cutting it
kind of
close.
flew around a little bit. And they're like, okay, yeah, this is okay. We can do it. And they just kept going. They're like, can we do this? Yep, it handles all right. Let's go.
That is crazy. That is really something. And then, so you have it here. It says it's only been accomplished only one other time by Stephen Fawcett in the Global Flyer.
Yep.
There you go. There you have it. Are you ready to look up into the sky?
Yes.
All right, what do we have for this week?
Well, a couple of things. There's some, monumental moments in 2011 that you can always go out and check. And there's also a holiday greetings from the commander of the space station. So you can see from space Yep.
Holiday greetings from
Wednesday.
space.
I know. It's sweet. So Wednesday is December 21st, which marks the longest night in the year for our Northern Hemisphere listeners.
Okay.
Yep.
So that's the
And
night to play Tor.
yeah. Thursday and Friday, the 22nd and 23rd, the Ursid meteor shower is going to peak. So if it's moon free, and it's only about 10 to 15 meteors an hour, but it might be a good observation.
Yeah, oh yeah, absolutely.
So the 24th is new moon.
Yeah, Christmas Eve, new moon. Cool.
Yep. And
also on the 24th, what, about 8 p.m., you can go out and see Orion in the southeast.
Yep, and then look down to Sirius, which is one of the really bright stars for the Northern Hemisphere. Flashes, very vivid colors even. So it'll kind of do red and blue off and on.
Pretty. Little light show, little Christmas light show.
Yep. Christmas lights in the sky.
Yeah. Yeah, cool. Well, so I think that's everything we have for the whole show this week, isn't it?
I think so.
Now, a point of note is the science will take a vacation next week, right?
Yes.
For the last week of the year, there won't be a show, but then we'll be back in January. We're going to take it off and play a lot of Tor. No, actually, I think you're doing a family thing, and I'm going to be playing Tor, so I actually have a superior plan in place. So sorry about that, Heather. Heather, I know you're not feeling great, so thanks for coming on and doing another excellent week in science with me. We powered through it, even both of us with our colds. We
powered through. Yes.
Yeah, that's awesome. Well, everyone, SciByte is traditionally live on Tuesdays at 7:30 p.m. Pacific over at jblive.tv, and then it's released for download on Wednesdays over at jupiterbroadcasting.com, where you can check the show notes with links for everything we talked about today. Lots of goodies in there. Heather, another great week. Thanks for joining us.
Yes. Thank you for having me.